In this video, we are going to look at precipitation reactions. A precipitation reaction is where you have two aqueous solutions, and when you mix them together, they cause a reaction, and the product is an insoluble ionic compound. That insoluble compound is called a precipitate. So, a precipitate is just the solid that is formed from two aqueous solutions when they undergo a precipitation reaction. So, let's go through and write a precipitation reaction. Let's get some practice. So, if you recall, a precipitation reaction follows the generic AB plus CD yields AD plus CB. So when I write out my reactants, the first thing I want to do is figure out and predict what products will form. So we have aqueous solutions of sodium chloride, and I know the state of that is aqueous because that's what the problem gives me. And then I have lead 2 nitrate. I also know that's aqueous because the problem tells me it is aqueous. So when I predict the products for this, I am going to switch my two cations. So the sodium is now going to become partners with the nitrate. It's going to switch places with the lead. And then the lead is going to switch places with the sodium and become partners with the chloride. So this is the first step. You want to predict the components in the products. What that really means is swap the cations and then just put them with the partners. Notice that when we do this, we're not trying to carry over all of the subscripts. I'm just carrying over the ones that don't change the identity. So for example, with nitrate, nitrate is NO3. I had to take over that entire NO3, but notice this 2 right here is just to make it charge neutral, so I don't need to bring that over. The second thing you want to do is create, actually, I don't want to say create. Let's say we're going to make sure our products are charge neutral. We want to make sure our products are charge neutral. So I need to go through and identify the charge on each thing present in my reaction. So I know sodium is in group 1, so it is going to have a charge of +1. Nitrate is a polyatomic ion, and it has a charge of -1. Since it's +1 and -1, those are already equal, and I don't need any subscripts. It's going to be charge neutral as I have it written. If you recall, double displacement reactions do not involve a change in charge. So whatever the charge is in the reactants, that has to be the same as my products. So if I look at lead in my reactants, I can't look at the periodic table and determine the charge on lead. I have to use the anion in order to do that. Nitrate has a -1 charge, and there are 2 of them. So I have a total of 2 negative things. Lead, I only have 1 of them. So in order to make this charge neutral, it has to have a 2+ charge. Since lead has that 2+ charge, it can't change when I go over to my product side. So this lead is still going to have a 2+ charge. Chloride has a -1. These are not charge neutral. So in order to make this charge neutral, I'm going to need to put 2 of my chlorides. Now, the third thing you want to do is write the states for the products. Sodium nitrate. Sodium is in group 1. Nitrate is part of the N rule. It is going to be soluble, so my state is going to be aqueous. If you look at your solubility rules, lead to chloride, chloride is a halogen, so it is in group 7. It is a halide, and most halides are soluble. However, one of the exceptions is lead. So this right here, my lead 2 chloride, is going to be insoluble, so it is going to be a solid. So this solid right here, this lead 2 fluoride, this is my precipitate. PPT is an abbreviation for precipitate. And in this picture right here, this is an example of sodium chloride reacting with lead 2 nitrate to form this yellow lead 2 chloride precipitate. So this is the precipitate that forms from that reaction. Now, the fourth thing you want to do is balance the overall reaction. So we want to balance the chemical equation. One of the first things I notice is that I have 2 chlorides in my products and only 1 in my reactant. So I'm going to put a 2 in front of my sodium chloride. Now that has caused my sodium to not be balanced, so I can put a 2 in front of the sodium nitrate on my product side. And by doing that, I have also balanced my nitrate.